A TCB is a dispatchable unit of work. So we've got our address space control blocks and our task control blocks. And then there's secondary task control blocks, STCBs, which allowed task-related information to be stored above the 16 megabyte line in memory. In all address spaces, we've got 3 z/OS tasks. There's the region control task, that's the RCT, the dump task, and the started task control, or STC. The RCT prepares the address space for swap out and for work after swap in. The dump task is used for scheduled SVC dumps, and the STC prepares the address space for work for which it was created. The address space extension block, the ASXB, is a logical extension of the ASCB. The ASXB is swappable in LSQA, that's the local system queue area, where the ASCB is not. Moving into batch address spaces, a batch address space is created when an initiator is started during JES initialization. As jobs are scheduled into the address space based on priority within a class, initiator attaches the program named in the PGM equals, creating a job step task, TCB. The job step task might then attach one or more subtasks which compete for processor cycles. If more than one task in an address space is ready to execute, then the address space might be dispatched on more than one processor. That address space then terminates when the command to stop the initiator is processed. And then there's the TSO user address space. This gets created when a TSO logon command is received from a TSO terminal, and it gets terminated when the logoff command gets received. The Terminal Monitor Program, TMP, accepts and interprets TSO commands, it gives control to command processors, and it issues that ready message that you hope to see. For each command, a task gets attached. When it completes, TMP responds to the terminal and waits for the next command. All right, started task address space. This address space is created when a start member is read from the z/OS console or from the command XX member of parmlib. STC attaches the program named on the exec statement of the started procedure, and it terminates when the started task terminates. The mount command and the ASCRE macro also cause the creation of an address space with the TCB structure. The dispatcher's queue is the queue of all ready work in the system. It's also known as the system work unit queue. The work element block is used to associate work, which is ready within the work unit queue, with the address space in which the work executes. The SVT, supervisor vector table, contains pointers to service routines, control blocks, and queues used by supervisor control. The highest priority ready TCB in the highest priority address space gets dispatched, and if there's no ready work when the dispatcher executes, an enabled wait PSW is loaded from a TCB called the no work TCB or dummy TCB. So now the task moves into service request scheduling. The SRB, service request block, is used to represent another type of dispatchable work in z/OS, usually of a short duration. The SRB executes at its own dispatching priority, which may be higher than that of any other address space, and it can execute concurrently on another processor. As you can imagine, lots more to be said about SRBs, and that's something we'll have you review in greater depth after we're done here. But for now, we're moving into program managing. To wrap things back around, z/OS views a job step as work. That work is called a task. The TCB represents a task, and it's maintained by the operating system and is related to a specific address space. The TCB control block of the task contains status of the task, and it gets restored when the task is redispatched, which includes the contents of the registers. You got all that? In our next section, we'll get into dynamic linkage.